undergraduate. Oh, you couldn't hear me. Do I have to start all over? No. So we're starting the Hettleman Talks with, it's the first event of our pan-campus university research week. We've been doing this in the past. It's been focused on undergraduate research week. And last year, the college and the rest of the campus got together and decided we should really celebrate what goes on across campus in terms of research. And so we have several events that we are planning this week, and the Hettleman Award Talks are the first event. But on Wednesday at 5 p.m. at Memorial Hall, NASA astronaut and UNC double alumna, Zena Cartman, is going to be sharing her journey from an undergraduate to graduate student researcher here at Carolina, and now training for NASA space flight. And I really recommend everyone to come to her presentation. It's going to be very fascinating. And then on Thursday, we're hosting a NASA Day, and it's a full day of workshops with all kinds of NASA program managers and directors of the various divisions. And the goal is to expose our faculty in terms of what are the funding opportunities for work that the agency will be interested in, and also to interact with our undergraduate students to talk about a pathway that could lead to the kind of career that Zena Cartman has pursued. So there are many events throughout the week in different schools, and they're all posted on our website, researchweek.unc.edu. And there you can see the various events that are occurring in some of the different schools. So this is a big deal for us, and to really recognize the importance of research at Carolina. And it's one of the major pillars of what we do here. So if we move on now to the Hellman Prize, it was established in 1986, and it was endowed by Phillip and Ruth Kettleman. The Hellman Prize is the most prestigious award that's offered by UNC Chapel Hill for research, scholarship, and artistic achievement, and it's focused on our younger faculty, which I think is really cool and a very important thing to do. And those that are eligible are second-term assistant professors and any associate professor that hasn't been in rank longer than 3 years from being promoted to be eligible for the award. Just a little background, Phillip Kettleman was a New York investment banker. Of course, that's how he made his money. But he was a member of UNC's class of 1921. And he came to UNC on a scholarship, and he never forgot that he would not have gone to college without that scholarship. And so as he progressed in his career, he really wanted to give back to the university and help younger faculty moving on. So after he graduated, he earned a master's at Columbia University, and from there he went into the financial industry, and he formed his own firm called Hettleman Company, and he became a member of the New York Stock Exchange in 1938. And then in 1975, he became a limited member of the First Manhattan Company and continued to serve as a senior partner in Hettleman Company. Phillip Kettleman married Ruth McGregor-Rea, and she graduated from Columbia University. Phillip passed away in May 1986, and Ruth in 2001. And so tonight, what's really important is that we are honoring their memories by honoring our younger faculty. And as I mentioned to some of you, we've kind of changed the format of the Hellman lectures. It used to be they would give 15-minute talks, 2 on one day, 2 on the other day, but we found that not very many people would come except in own departments. And what we wanted to try to do is make it more exciting. And so we thought having shorter TED-type talks would be a good way to go, where all 4 would present at the same time and then do a reception. We did that last year, and it turned out to be very exciting and useful. The 4 Hettleman Award winners developed a group that carried through during the year, and we expect these 4 to use the same going forward. Okay, so I'm going to introduce each of the winners one at a time. They will come up and give their talk, and I'm going to do this in alphabetical order. So we're going to start with Phillip Kettleman. He's an associate professor in Asian studies in the college. And what he's done is to merge traditional scholarly methods with digital resources and data mining techniques, which is very relevant today. And he conducted research on early China and other traditions. His research has garnered him strong international reputation, which was emphasized by the popularity of his first book, entitled The Emergence of Civilization Consciousness in Early China, History Word by Word. That was published in 2018. And what he did in this publication was to adopt interdisciplinary theories to track lexical changes in word meanings. And that extends from ancient China to modern culture. Ufa graduated or earned his doctorate from the University of Michigan in Ann Arbor in Asian languages and culture. In addition, he also holds a doctorate and a master's in linguistics and another master's in East Asian languages that he earned from the University of Southern California. So, Ufa, congratulations and welcome.
Thank you, and thank you all for being here today. So very conveniently now you know a little bit about my book. So I'm going to give you an overview of some of the ideas in it. I'm not going to be able to show you what I argue. I'm just going to state my conclusions, and you can read the book if you find it interesting. I'd also like to begin to by thanking Professor Nadia Cook for nominating me for this award. Without her support, I would not be here today. So, the title has changed a little bit, Coining Chinese Civilization, History Word by Word. So one of the things that I'm interested in is the notion of civilization and the concept of civilization in English and in Chinese, and how we can put them in dialogue. So a lot of ranges, a wide range of dates of the origin of Chinese civilization have been proposed. Archaeologists and historians propose dates ranging from 7,000 years ago to 2,000 years ago. So what's the right answer, and why does it even matter, and how do we talk about this? That's some of the topics that I'm interested in. So these widely different dates of Chinese civilization may stem from different definitions of the modern English term and concept of civilization from English, or language like other concepts of civilization. I think it might be more interesting, to ask a different question, which is what I do in my book, namely, when did civilizational consciousness emerge in ancient China? What does it mean? That is, when did speakers of the language of ancient China begin to feel the need to have a word that could articulate the notion of belonging to a civilization? I suggest that this happened around 2,500 years ago, around 500 BC. So my interest in this question began when I noticed passages like this from my colleague's work. This is from a book by Roland Sturks, a historian of early China, who talks about several sources, as you can see here, from the Warring States period, which is a bit after 500 BCE. They account how sages from antiquity engaged in acts of cultural creation or revealed feats of civilizing potentiality. Civilization brought a change in the habitat of both the living and the dead, writes Strauss. And he seems to assume that the authors of these ancient Chinese narratives had a concept of civilization in their own language. This made me want to figure out which words were used to articulate this concept, and if there was a single word which would mean something like somewhat akin to civilization in the old Chinese language. To answer this question, I of course have to establish a hermeneutic dialogue with English words since I'm writing in English. So I began to map the different meanings of the English word civilization and trace their chronologies using databases and methods in the humanities. Doing this provided me with a framework for how to use changes in word meanings to trace epistemic changes in worldview and thought, and how to link such changes to social political developments. This is the approach that I call history word by word. So let's look at a social historical context for the coining. The coining of the word is when you make a word or invent a word. So the English word civilization didn't exist before 1760s. It was coined at around that time. Before that, you couldn't say Chinese civilization. You had to say something else. So that's what I'm interested in, how that makes a watershed in European civilizational consciousness once you can articulate this term. There is a social political context, which are basically the historical developments from the 16th to the 19th century that eventually led to the formation of nation states. These developments included, as I said here very briefly, the increasing bureaucratization of government administration, which led to a shift from charismatic bureaucracy from charismatic power to bureaucratic authority, to use some of the terms of Weber's theory. A group of professional political thinkers then emerged whose task it was to rethink the relationship between state and individual. And these masters of statecraft, I argue, were the people who eventually coined the word civilization, and also relying on other people's research here. So here is an example of one of the very first instances of the word civilization in English language. If all mankind arrived at an equal or even tolerable degree of civilization, what would it signify? Where one was born, or what particular district one became a citizen. So the semantic structure, this is what I do as a linguist, I guess, who's approaching intellectual history, mapping the semantic structure of a universal concept of civilization. Here you see how I propose it. It can be mapped like this, including 5 semantic molecules: progress, civility, police, distinctions, and universality. Individuals improve with respect to civility and social formations with respect to police, which I here use in the old sense of laws and government institutions, not the police force. So this leads to a set of distinctions between us and them, the barbarians and the civilized, and a civilized present versus a barbarian past. And this is supposed to be a unidirectional development based on a set of values assumed by the people who use this word to be universal. Of course, they were not, but the people who point this word assumed it to have a universal scope. So I call it the universal concept of civilization. Later on, in the beginning of the 19th century, a new concept of civilization occurred. And I'm mapping these different concepts because then we know what we're talking about when we say civilization. And that's more akin to modern concepts of culture. And it's defined, or has been defined, as the totality of characteristics of the collective life of the group. It's a list, basically, of descriptive characteristics that do not include value judgments. It's very different from the universal concept of civilization that we just talked about. And this new ethnographic concept now allows scholars to talk about the unique characteristics of Chinese civilization, Western civilization, Egyptian civilization, etc. While the universal concept of civilization is descriptive and universal in scope, this new ethnographic concept is descriptive and relative. In the late 19th century, another concept emerged, the archaeological concept, with the advent of the discipline of archaeology, also the handmaiden of nationalist ideology among the So this came to be coined in this, using the same word but in a new meaning. And usually, archaeological definitions of civilization are defined as a list of criteria that a state formation in the ancient period has to meet in order to classify as a civilization. Those typically include social stratification, town formations, written language, and monumental constructions. Lists vary, and if they vary, then the definition of civilization might vary. So if written language is included, then Chinese civilization can only be 3,200 or 300 years old, because the oldest Chinese writings are around that old. But if you exclude written language, which some scholars do, then you can project the origin of Chinese civilization according to the archaeological definition back to the Neolithic, if you want, depending on how you do it. So it becomes kind of a quibble over the definition of the concept of civilization. And that quibble is often done in the synthesis. So here I just summarize in this table very briefly kind of the coining of the word civilization, and which I see to be the point where civilization consciousness in modern Europe was crystallized in the middle of the 18th century with the advent of the universal concept of civilization. And then later on, also informed by other concepts, which I will not focus on so much. So, a little bit about my methodology, as you already know. I call it history word by word. What do I mean by that? I use the lexicon or the mental dictionary in people's minds, collective minds, as a historical source. So I use lexical semantic changes in word meanings, which I see to reflect and inform changes in worldview in collective consciousness. And how can I do this kind of research? It's difficult to do if you have to read everything that's written in a certain period, but digital humanities, big databases, and research using text mining strategies allows us to do this kind of research, tracing the meanings of words and using them as sources. So I also use something called the Natural Semantic Meta-Language Framework developed by a Polish linguist situated out in Australia, Anna Wiecznicka. And this allows me to do cross-cultural comparison of concepts. And the idea is basically you take a complex concept like civilization, which there may not be a kind of simple equivalent to in other languages, and then you break it down into semantic molecules, which are lexicalized or exist as single words in other languages, and maybe can then serve to paraphrase this common concept in the comparison language. So, how can we define the universal concept of civilization, which is what I'm trying to see if we can trace early. It can be kind of broken down into this long kind of definition as here, a social formation. Basically, this is what we mean when we talk about Chinese civilization, at least in the universal sense. A social formation that has undergone a universal process of change for the better, operating on individuals and social formations along dimensions of civility and institutions, and which resulted in the establishments of value-laden distinctions between self and others, and a civilized present versus barbarian past. It's a long thing, and political scientists around the 18th century needed to have a single word in order to not to say all this every time they wanted to convey the idea of civilization. So that's also part of the idea of lexicalization. People create a new word. So basically, comparing, kind of figuring out whether we have civilization or consciousness in kind of that definition in early China, this means to see if we have a similar concept or a concept that can be broken down into similar molecules in Old Chinese in the pre-Qin period or the ancient Chinese period that I'm studying, or before 221 BC. And as you see here, you've seen this list before. These are the social historical contexts in which Europeans coined the word civilization in the 18th century. And the same list, formation of ruler-centered states, shift from charismatic to traditional authority and bureaucratic authority, and emergence of a group of political thinkers. That occurs at a very abstract level. Of course, the details are different, also in the modern states. So the kind of situation where this concept can be coined also comes about at around 500 BCE. So here we see the words of Confucius in the Analects, and it's one of the first passages from the early Chinese corpus. And this passage may be from the 5th century before the Common Era, maybe 4th, some debate when it was composed. But it shows one of the earliest instances of the use of a word, like this word here, weapon, which has been proposed to be translated as cultural civilization in this passage, which is one of the key passages. And there's also a king who has the name culture of civilization. So Confucius says, after this king died, he lived around 3,000 years ago, 500 years before Confucius, did civility and civilization when not remain here? If heaven was going to destroy this culture of civility or civilization, those of us dying after would not be able to participate. So I'm looking at the semantic, basically, evolution of this word when to define to look at patterns in the corpus using text mining techniques to see how the word started to have, like a long time ago, the basic meaning of pattern, more than 1,000 years BCE. And then from that derived things that are decorated, the pattern you put on an object and it's decorated, and decorated objects are beautiful compared to plain ones. So you have this derivation, which is typical in many languages, going from root to abstract. So that's a typical pattern of lexicalization that occurs in most languages. And then you go from beautiful, here's the crucial step around 500. This is where I contribute a little bit. I think this theory that it happened at this time, so civilizational consciousness emerged with the point of this word in this term. In the term, the meaning of morally refined is given to the word. When from beautiful and then from morally refined, we derive the word, the meaning civilization. Okay, so here we see, stepping back in the period before the word came to mean morally refined or civilization. Here you have an example of what it meant then. Then it meant beautiful, as I just stated, and it was referring to people as awe-inspiring and beautiful. So here is the ruler of the state of Rome, described as awe-inspiring and beautiful, in parallel to his martial powers as well. And this passage from a little later, but it refers to the kings from the pre-500 BCE period, going back and looking at how they had to beautify themselves using decorated jades and embroidered robes to make themselves awe-inspiring, to basically have their subjects obey their orders. So this was an early pre-civilization meaning of the word ready. Now, the new post-500 BCE meanings that arrived with Confucius are illustrated here in the text from the 3rd century, which will continue later on as well. This is the text that illustrated very clearly, where it talks about the noble man who is respectful, reverent, attentive, cautious, but still generous. Indeed, here you have the definition of the term. This is what is called being utmost civil, or having civility, having these patterns of civility. And you can go and take this notion of civility and then extend it to state formations. People are civil, but what about a civil state formation? It has civility or civilization. So here you have a passage from the Analects where the word red is used as meaning civilization. The master said, as for the Zhou dynasty, 2000 BCE to around 2200 BCE, when viewed on the background of the two Poseidon dynasties, how splendid its civilization. I follow the ways of the Zhou. So here you have an example of the use of the word red in this meaning. So just to summarize, so crudely, the main kind of period that I'm looking at is before or after 500 BCE, and there's this big shift from the word when meaning beautiful applied to people at the top of the social hierarchy, the nobility who decorate themselves to basically show their members of their aristocratic clans, and it was a prerogative of the hereditary nobility. Then later on, with Confucius, he changed the meaning completely and introduces when in the meaning morally perfected to refer to the people at the top of the moral hierarchy, and therefore also by extension civility and civilization. It's a little bit similar, let's say, to the Greek word philosophy. You can see some parallels to the change from the Bronze Age into the Classical period, where you have this word that meant beautiful in the Homeric epics in the pre-500 BCE period, in the warrior aristocracy of Homeric heroes. And heroes could be judged by their appearance to be beautiful. You were a man of imposing aristocratic appearance. Then later on, by Plato, the same word also came to mean morally good and the definition of philosophical concept of goodness. So there is a parallel here, which I can go into. So let me just skip these. So there is a set of terms. When is one of them? There's also a lot of other terms, customs, barbarians, etc., that more or less, give or take a few centuries, are coined in these new meanings around 500 BCE and articulate this civilizational consciousness at this point. And you have this sociological, socio-historical context of switch from centralized states to bureaucratic states, and the switch from charismatic power to bureaucratic authority. I would also just end by the remark that this is not just relevant for ancient Chinese history. Leaders today in China are trying to redefine national identity in the post-Mao era by looking back at the ancient past and anchoring the modern Chinese nation in the ancient past, going back to this concept. So I'll end here because that's a topic of a different topic. Thank you very much.
Thank you, Ruth. What we're going to do is hold questions, and at the reception afterwards, I really encourage you to interact with our speakers. So our next speaker is Kavita Singh Getchi, and she's an associate professor in maternal and child health in the School of Public Health. Kavita is a globally recognized leader in the field of maternal and child health. She seeks to improve the health and well-being of vulnerable populations of women and children. And much of her work is focused on reaching these populations with interventions and evaluating national efforts to improve maternal and child health. She has several publications on the influence of gender inequality and women's economy on health outcomes. She's also explored the role of poverty reduction in child health outcomes and the efforts required to reach stigmatized groups needing HIV interventions. Her evaluations take mixed methods of approach and are designed to inform programs, policies, and ongoing management. Kavita received her doctorate in population dynamics from Johns Hopkins in the School of Public Health. She holds a master's in medicine and health sciences from George Washington University and a bachelor's in biology from Cornell
Thank you so much to the Vice Chancellor for Research for the introduction, and thank you all for coming to hear our talks today. So my topic is maternal and child health as a human rights perspective. I've always seen a focus on mothers and children as a human rights issue. The Universal Declaration of Human Rights actually states that motherhood and childhood are entitled to special care and assistance. Yet unfortunately, millions of mothers and children around the world do not get any special care, and in fact, they don't even get the most basic care. About 20% of pregnant women end up delivering without the help of a skilled provider, often in a home or non-facility environment. The majority of pregnancies do proceed normally, but in about 15% of cases there is a complication, and these complications often arise suddenly, and some can be fatal if not treated quickly. Thus, the importance of all women having access to skilled care. Children under 5 have the highest mortality of any age group, with the exception of the very elderly. They are very susceptible to infectious diseases, which can progress very rapidly from uncomplicated to severe if not treated quickly. They are also susceptible to undernutrition and dependent on other people to take care of them and to advocate for them. Globally, we estimate that there are nearly 300,000 maternal deaths around the world, and there are over 5 million deaths to children under 5. Within the deaths to children under 5, 2.5 million, or 47%, actually occur in the very first month of life. So that very first month of life is a very vulnerable and risky period for many individuals. The majority of these deaths are occurring in low and middle income countries, with a high proportion occurring in sub-Saharan Africa and South Asia. And what is most tragic is that the majority of these deaths could have been prevented with known interventions. So it's not that we don't know how to save these lives. It's often that these women and children are not able to access potentially life-saving interventions. There are many reasons for this lack of access, including poverty, distance to health facilities, barriers in terms of transport. There are also issues of conflict and marginalization. Lack of women's empowerment is also an issue. In other cases, care is sought, but the quality of care, the quality of health care is too poor to be helpful. So I'm just going to focus on two of my main areas of research. The first is on evaluating national programs focused on maternal and child health. I've taken a real interest in looking at programs that are driven by countries, looking at local solutions to improve health for their mothers and children. And the second area of work is my interest in documenting and assessing low-cost, low-tech interventions for newborns that can work in low-resource environments. So in terms of evaluating national programs, I had the opportunity to evaluate a project called Project Fibroblasts in Ghana. I worked with several colleagues from UNC on this project. Also working on a similar ongoing project in Ethiopia. And talk about these two projects together because both of them take a quality improvement approach to assessing barriers in terms of health facilities providing high quality care. And they also take a quality improvement approach in thinking about how to increase the community's ability to access care. So in these projects, quality improvement teams form at the level of the health facility or the level of sub-district. They come together to identify these barriers, and then they use what are called planned study cycles, as in the figure above, where they test out a specific intervention. They call them change ideas. So these interventions are all locally driven, low-cost interventions. They implement that change idea and they study it over time by looking at the data from that health facility to see if it's leading to improved outcomes. Some examples of these simple change ideas are midwives giving their phone numbers to pregnant women so that if she goes into labor and can't get to the facility, the midwife might be able to arrange transport for her. Another change idea was having midwives use cartographs, which are a simple tool to monitor the progress of labor. These cartographs alert midwives if labor is not progressing normally and quickly enough. And a third example is that in some hospitals, they started to triage sick children on the fly and give them priority for treatment. So this graphic is just showing a map of Ghana over time. And both the projects in Ghana and Ethiopia started with small pilot phases. So wave one here started with just 27 health facilities in northern Ghana. The project started in the north because the north has worse health outcomes than the southern part of the country. Then there was a massive scale up to the rest of the north, so you can see the increase in the target population from wave one to wave two. And then in the south, there was also a pilot phase and then a scale-up phase. And by the end of the project, the intervention was trying to reach the entire country. So with these projects, often the pilot phase is often more programmatically intense. The project spends more time with the quality improvement teams, whereas in the scale-up phases, they turn over more of the responsibility for the training and supervision to the government. So in many ways, the scale-up phases are reflective of sustainability and what might happen when the project funding ends, and the government is expected to continue the quality improvement approach providing care. So for the evaluation, I'll just talk about a few results from our evaluation of Project Fibroblasts in Ghana. We used a mixed methods approach, and we used impact analyses to understand ideas was associated with reduced underlying mortality. This was likely because closed teams or facilities that tested more changes really integrated their quality improvement approach into their philosophy of providing. We did some team assessments to understand how the teams were functioning over time and how they were working together and what made some teams high achieving and high functioning. And we found that the most successful teams were very good at engaging the community, identifying barriers. They did a lot of community outreach, and they also received a lot of support from their management. We did some qualitative assessments to understand how mothers were reviewing and receiving, what were their perceptions of the care that they were receiving. And you can see from the quote above that respectful care was very important, and being treated in a respectful manner was very important. In terms of cost effectiveness, not surprisingly, we often found the scale-up phases were more cost effective than the pilot phases. They were reaching a far greater target population. I'll now turn and talk a little bit about my work on newborn health interventions. So, as I mentioned, we lose nearly 2.5 million newborns globally every year in the very first month of life. And even within the first month of life, the first week, and even the first day are particularly vulnerable. And some studies up to half of the newborn deaths occur on the very first day. And we often think of neonatal health as requiring a lot of technology, incubators, and highly skilled neonatologists. But we also need interventions that can work in low-resource settings where there is no electricity, no incubator, and no highly skilled neonatologists. So some of my work has focused on very simple interventions for newborn health and focused on the first month and days of life. So one of these interventions is called skin-to-skin contact. And this is when a newborn is placed skin-to-skin against his or her mother very soon after birth, and both of them are covered with a cloth or a blanket. This is an important intervention for several reasons. One of them is that newborns, particularly those who are born premature and or below birth weight, are very susceptible to hypothermia. Newborns don't regulate body temperature as well as older individuals and need to be kept warm, and the mother actually serves as a natural incubator. I've also found that skin-to-skin contact promotes early breastfeeding because the baby is in a natural position for breastfeeding. And early breastfeeding is associated with a 22% reduction in neonatal mortality. It's also helpful in promoting mother-baby bonding, reducing infant and maternal stress. Unfortunately, over time, health facilities have come to separate mothers and newborns immediately after birth. Often this is to do routine procedures, but we've actually found that many of these procedures can be done while the newborn is in the skin-to-skin position, or some of these procedures can actually wait so long as the mother or newborn does not have complication. And unfortunately, coverage of this intervention is very low right now in Nigeria. Only 10% of newborns are put skin-to-skin against their mother, and about 26% in Bangladesh. So there's a lot of work to do in scaling up this particular intervention. Another area of research I'm very interested in is newborn resuscitation. About 8 or 9% of newborns have trouble breathing immediately after birth. And this is due to many reasons, but in general, they're not getting enough oxygen. And if they have some simple intervention within the first minute of life, we call this the golden minute, they can survive. And luckily, some of these newborn resuscitation interventions are very simple, that you don't need a highly skilled provider to perform them. They start with a series of steps, starting with just simple drawing, warming measures. And if that doesn't work, the health worker goes on to do some tactile stimulation. It's only in a small percentage of cases where more complex interventions are needed, such as back masking, ventilation, or chest compressions, which might require the aid of a more highly skilled provider. Again, we need to do a lot of work in terms of more training of both formal and informal health workers to be able to perform these interventions.
Our next speaker is one that's more close to home. I remember when she was being recruited to UNC. A lot of excitement about her coming and her work. And that's Lee Kwan. She's in the Department of Pathology and also Associate Director of the McAllister Heart Institute. Lee is conducting groundbreaking research with implications of basic mechanisms of cellular differentiation. Her work on regeneration and repairing injured heart includes using stem cell approaches to restore cardiac function following heart attacks. By seeking to understand the molecular basis of cardiac muscle cell function, her team is striving to improve efficiency and clinical applicability of cellular reprogramming in heart tissue. Lee holds a doctorate in molecular, cellular, and developmental biology from the University of Michigan, and a bachelor's degree in biology from Brown University.
First of all, I want to really thank my department and also MHI leadership for nominating me, and also the Hettleman Prize committee for selecting me to be one of the winner. And also I want to congratulate the other three awardees, and especially Grant Wong, who is also my good friend and collaborator, for their remarkable scientific contribution and winning the prize as well. So today, I'm going to really share with you a series of stories about how I really grew up as a scientist on the journey looking for ways to mend a broken heart. Heart disease is actually the #1 killer for both men and women worldwide. And perhaps for every single cardiologist or cardiovascular researcher, our ultimate goal is perhaps to find a cure for heart disease, or at least relieve the symptom or pain on those broken-hearted patients, such as this poor baby suffering from the congenital heart defect, and also this adult heart attack patient suffering from the chest pain. My passion in heart is really kindled by this kind gentleman, Dr. Rolf Balmer, who used to be a neurobiologist at University of Michigan. And back to the 1980s, he was looking through thousands of flight embryos, trying to identify some regulator in the nervous system. Accidentally, he actually found a gene active in the heart. Instead of throwing it away, he pursued with full curiosity, even generate commuting embryos that have this gene. They do not have a heart. So he named this gene T-Man, following the Wizard of Oz character that also has a heart. Soon after he discovered this gene, researchers also identified the human corresponding gene, actually called NKX2.5. And importantly, they find out mutation of this gene not only cause human congenital heart defects, but also adult conduction defects, such as Eileen-Nichols family, where 12 people spanning from 5 generations all have heart defects. Eileen, who lost her mom, younger brother, and her own son, said, "We always knew there was something in our makeup that was wrong." So they are a team mutation family. So Eileen's family is really convinced and impressed the importance of basic science using the simple life form, such as fire. So the Wall Street Journal actually made a series of reports of this story, and I was really fascinated as a 20 years old girl, and I decided to trace down Rolf, and fortunately I joined his laboratory, and together with another grad student in the lab, we actually worked together looking for friends of T-Men and how they pattern the flight route. During my PhD, by really using the powerful genetic tools in the fly, I studied how this little group of cells during my postdoc under the supervision of Dr. Deepak Srivastava, where we used T-gene as the reporter to enrich heart muscle cell derived from the stem cell and introduce a map to repair damaged heart. We also used a highly conserved microRNA called microRNA-1 and developed some of the mirror-based therapy. And most excitingly is the cardiac reprogramming approach, which I will focus the rest of my talk on, where we just use 3 factors, and I want to emphasize all 3 factors were identified and also fully characterized using model models. Why this is so exciting? Let me start from the beginning. And at that time, we were particularly interested in another major cell type in the heart called cardiac fibroblasts. So usually, under healthy condition, fibroblasts provide support structure and secrete molecules to make sure the whole heart functions properly. With injury, cardiac fibroblasts will undergo remodeling process and become a scar. At that time, we wondered whether we can hack this scar-forming fibroblasts and perhaps become something useful for us, the cardiomyocytes. And after overcoming numerous technical and conceptual difficulties, in 2012, for the first time, we demonstrated, indeed, we can use the 3 factors I mentioned earlier to convert the scar-forming fibroblasts into heart muscle cells. And particularly in a mouse model of heart attack, we were able to show that such conversion can translate into functional improvement and scar size reduction. And showing here are 2 pictures. And one is from the non-treated heart, and the other is from the reprogrammed heart. And the blue color really delineates the scar, and you can see compared to the control heart, and the reprogrammed heart has a much reduced scar. And importantly, when you look at the new muscle tissue around or within the scar, and by playing a little genetic trick, we can find those cells not only positive for the muscle marker, but also they are positive for the fibroblast lineage marker, indicating they indeed coming from the fibroblasts. And this research really triggered excitement in our field. And however, at that time I thought there are still a number of questions remain to be addressed before we can bring this approach to clinical test or even clinical trial. So that including how to really improve the efficiency, purity, and yield of the induced heart muscle cell, and how to make this conversion as precise, safe, simple as possible, and also how to minimize the side effects. And with the excitement and also the number of questions, I started my own laboratory at this beautiful university. And during the early years, and we still focus on understanding the biology of cardiac reprogramming, by really understand what's the role each reprogramming factor plays, and what's the dosage requirement, and perhaps the time when we need to introduce each factors, we actually perfect the recipe of the reprogramming cocktail. And also we study the regulatory pathways by which that actually regulates the cardiac reprogramming, and therefore we also fine-tune the process. Through all this effort, we improve the efficiency and the yield of the reprogrammed heart muscle cell, and also we simplified and streamlined the conversion process. So our research at that time again gained international attention. However, I stressed again the importance of using basic science and the power of it for the advancement of translational efforts. So now you might think, okay, we can just simply introduce the optimized cocktail to any patient with heart attack. That's probably the answer is probably no, because every single heart attack patient might be different in their genetic makeup, in their disease condition, and in their scar size, or even the time when they sent to hospital. So ironically, the team at my still dropped died from the heart attacks if we just give that crude therapeutic approach. So we decided to another closer look and to figure out really personalized approach for perhaps each patient. And at that time, reconstructed the molecular route of how a mouse cardiac fibroblast gets converted into an induced heart muscle cell. And so that we can use the power of single cell optics to simulate the process with experimental validation. And also we can identify the intermediate population along this process and assign the pseudotime to the conversion, so that we can really go back to this route and take advantage of the powerfulness of the single cell and to see what's really going on in each individual cell. And 2 years later, actually a couple of months ago, we achieved the goal in the human system. And slightly different from the mouse reprogramming, we find the human reprogramming actually form a bifurcated trajectory where we identify a decision point. A fibroblast either decided to go on to become a muscle cell, or they decided to go back to their original cell plate. Also, we developed a new mathematical algorithm called cell-fate index, so that we can compress the genomics information in a cell and to evaluate or predict how far a cell goes from a fibroblast to a heart muscle. So, but through this effort, we happily share with the field, and perhaps we'll now develop a Google map for cardiac reprogramming, and we can assign a fibroblast to a car looking for the fattest and the shortest way to go home, and here is the cardiac myocyte fate. And such a Google map can provide real-time guidance to avoid turnarounds, to avoid roadblocks, and also with the facilitation of the gas station and hospital, where we identify as a medical facilitator, the car can find the right way to go home. And the cell-fate index can also be shown on the car gauge for prediction and guidance. So that in the end, so perhaps the treatment for each individual heart attack patient can be very personalized, and we can tweak every single scar-forming fibroblast in a specific patient, and to make those cells into heart muscle cell, so that heart patient can really walk out of the hospital smiling like in this picture, without the need for transplantation or the open heart surgery. And perhaps our concept can be beyond heart disease, because we can set up where the car really wants to go. And here the fate can be maybe other cell type fate as well, such as blood cells, skin cells, neurons, and endothelial cells, and liver cells, and perhaps even cancer cells, so that the cancer cells can find the right way, go back to the original healthy status. And I'm particularly excited about UNC's newly formed computational medicine program, and also the program for precision medicine in healthcare. And I think with all the synergized effort, such dream can be perhaps realized earlier than we expected. And UNC will again take a leading role in such effort. So I want to give the credits really back to the people who did experiment and generate the data, and all the former members from my lab, and also the current members, and I think all of them are kind of in audience. I also want to thank wonderful collaborators, and try to include everybody. Of course, Greg Wong's name is here as well, and also funding sources and core facilities. But what's the take-home message from TMAC? So actually now I'm starting to call me Lauren, and I purposely wear the black shoes. So TMAC will tell you really to help him to find the cure for heart disease. And Dorothy perhaps need to work with a team, such as Lion, like the Scarecrow, and in our case, our wonderful collaborator, bioinformatician and mathematician and computer scientist, and like epigenetic expert like Brad. And although the yellow brick road to the final destination is full of difficulties and obstacles, Dorothy always goes with full optimism and courage. And also, we always like to enjoy the landscape along the road, and perhaps sometimes picking up one or two flowers, like when we identify the role of splicing factor and epigenetic factor. Sometimes it's really fun and fruitful. Okay, master site. So you might
Okay, thanks, Lee. That was great. So our last speaker, I also remember the recruitment of Greg to UNC. We had a good class of people that recruited during that time. Greg is an associate professor in biochemistry and biophysics. He's also a member of the Hamburger Cancer Center. Greg's work focuses on the epigenetic changes that occur in cancer, along with the development of new therapeutics. He uses a lot of cutting-edge technologies, and that includes biochemistry-based discovery tools, CRISPR-Cas9 gene editing tools, and next-generation sequencing and genomic profiling. He leads a team to dissect and to understand mechanisms and pathways by which particular gene alterations will lead to development of cancer. And he's really heavily focused on myeloid leukemia and prostate cancer. Now, Greg did his doctorate work at UC San Diego, and then postdoctoral training at Rockefeller University. He also holds a master's in cancer biology and a bachelor's in biochemistry from Yale University. Right?
Thank you, Terry, for this very nice introduction. All right. First, it is absolutely an honor to be here and to share with you some of the research interests in our doctrine. As this slides indicate, I'm mainly going to talk about two things: the chromatin and the cancer. To place this audience that covers humanity, public health, and medicine to the same perspective, I'd like to start with something we're all kind of familiar with. For example, the movie series of X-Men, because this movie is already told that the genetic information of human cells is encoded in these DNA sequences. The makeup of DNA sequences essentially define the traits and phenotype of human cells. However, it is not a good picture. As we know, the DNA must be confined in this specialized cell compartment called the nucleus, which is the red region here in the center. To do so, the very long DNA fiber must be wound and packaged around a very specialized protein spool, which is made by the history proteins, just like this. And such a combination of DNA fibers and history spools essentially constitute chromatin. For long, it has been known to the field that chromatin modification is actually subjected to various chemical modifications, either on the DNA side or on the histone side, creating variations. As this little circles in different color are shown here in this slides. To give you a view of how this chemical tag is like, we can focus on this small area and unique. And now we're looking at a lysine, which is an amino acid commonly found in human histoproteins. And it can be chemically modified by chemical tags, such as silation on the left side and methylation on the right side. And it has become more clear to the field that this small chemical tags on chromatin actually can serve as the regulatory mechanism and molecular switching system for the cell to control and regulate the activity of DNA on the underlying genes. It is very important, as we already mentioned, for example, in the muscle cells, that the gene that is critical for the functionality of muscle cells must to be very active in the muscle cells. However, the same gene in the neuron cell cannot be active at all. Conversely, the gene that makes up the traits of the neuron cell must be very active in the neurons, and then not much so in muscle cells, right? And this phenomena is very important for generating a wide diversity of cell types during development. Essentially, during the process of differentiation, the stem cells must make multiple decisions at this different turning point of the cell-based decision making. It's sort of like a model moving down the hills and at different places. The model makes different turns, and in doing so, a wide range of different cell types can be produced. And we believe the chromatin and the embedded tagging system are very important for the cell to make this kind of choice or decision-making processes. So part of the research interest of mine has been devoted to understanding this molecular switching system that is related to the chemical tagging system on the chromatin. For example, as a trainee, I have studied a class of enzyme that can add a particular modification to histoproteins, and some other people in the field have found that this process can be reversed with a different set of enzymes. And we also start to appreciate, besides this enzyme system that essentially acts as either on and off switches, there exists yet another class of protein we call effectors. And these effector proteins combine to chromatin modification of tags and are critically involved in the maintenance of gene activity controls. As a good analogy, it's sort of like a lock on the switch to ensure the position of the switch will not be easily changed, because this switch was very much important to the cells. In order to identify this fascinating class of effector or locks in the cells, our laboratory has taken on their biochemical identification approaches. Essentially, we can use the histopeptide that carry the chemical modification of our interest, and carry out a sort of fishing experiment to essentially identify the effector protein of the cells. And without going into the details, we have found different classes, effector proteins in a cell, some of which are shown here. As you can see, this protein band is indicating the affinity of the interaction between effector proteins, and this series of this series of chemical tags. And as you can see, this chemical tags accompanied with very little variations. This indicating the recognition system that acting on the protein tags are not only diverse, but can also be very specific. In collaboration with structure biologists, we also start to gain the detailed view in terms of the interaction between this different class of effector proteins and the chemical tags on chromatin. And along the way, we see a very fascinating structure identity. For example, this cage-like structure and this clamp-like structure, which are utilized by effector protein to really engage the chemical tag that are the histone proteins. This sort of discovery then allowed us to dig into the functionality of this effector protein in the stem cell biology or in the development, for which I'm not going to be able to talk about the steps. But another very fascinating thing about this is a lot of the chromatin-related factors we and others have been studying are actually heavily related to cancer development. They were found either frequently mutated in cancers or found to be dysregulated in one or many different types of human cancers. So in addition to a fundamental theme of my research laboratory, naturally another research direction of our lab of efforts is trying to dissect in the relationship between the chromatin dysregulation and cancer development. Due to such a prevalent mutation pattern that hints of the chromatin modified proteins, we favor a view that the chromatin, the cancer actually very much frequently arises due to the alteration of the chromatin modification. And I come back to this analogy of a model and a landscape, for example. The alteration may, like creating a block, as shown here, on the path of this model, and which then locks this model in a certain state with less differentiation potential and also very much more proliferation potential. And this type of thinking would be very important for cancer therapeutics, because if we be able to identify what exactly switch or locks is utilized by cancer cells to maintain their malignancy state, we may be able to have a way to treat the cancers. That is exactly our lecture is studying. To give you an example, recently we have studied into the somatic mutation of DMT3A, which is an enzyme that can add on top of the chemical tag called self-summarization onto the DNA. And the somatic mutation of DMT3A was found very common in the aggressive form of acute myeloid leukemia, which is on top of the hematological malignancy showing very poor prognosis in the clinic. To understand the chromatin alteration in this type of cancer, we utilize lots of the deep sequencing technology without showing a lot of the details of what we have been done. Essentially, what we found is somatic mutation of DMT3 not only causes the decrease of the DNA methylation, which is expected, but more importantly, it also led to the increase of the histone modification shown as indicated here. And this change on the histone side eventually led to the engagement of this set of effector protein that we have been talking about. And this effector protein is sort of acting like a lock and make the cells in a state of malignancy. And this finding has a lot of implications, because if we be able to find a way to unlock this effector proteins, we may be able to treat these cancers. That is exactly what we did. We utilized our chemical inhibitor, as shown here in this red circles, which is developed by other people, can unlock this effector proteins. And to our excitement, after the treatment, we found all these tumor cells now very much become differentiated ones, which is considered to be normal and not cancer cells. So I'd like to use this cover of this book to give you a summary. We're really at a very exciting stage of discovery for chromatin biology. And admittedly, cancer is a very much complicated disease. And to some, it is deemed as the king of all malady. Probably heart disease is a queen. And the problem with cancer and heart disease, it has been very challenging and has been very difficult. But I believe with the effort made from the protein field, cancer field, and many other fields, and someday we'll be able to find a way to at least control and even cure this very terrible human disease. And if not all human cancer types, at least a good portion of a certain subtype. With that, I'd like to make some brief acknowledgement. Have been very fortunate to work with a set of very talented training online, and it has been a great privilege to work with this group of collaborators, these are on-campus or outside the UAC, and some of them are actually here in the audience. I'm very grateful to my home departments, Department of Biochemistry, chaired by Dr. Leslie Priest, who's in the audience, and Lambert Cancer Center, directed by Shirley, as well as outstanding biology program led by Terry and Bradstreet. And finally, a lot of congratulations to my co-awardees for this very special recognition. I'll stop here. Thank you for your attention.
Okay, let's thank the 2019 Hettleman faculty for their there's a reception in the back, and I really encourage you to spend some time interacting with these four incredible individuals. Thank you all for coming. And